Hi, this is Mr. Shumway. This video clip explains how to calculate the acceleration of an object in free fall. So if you've already done calculating constant acceleration, so you might be able to do this without this video clip, but if you get stuck, here you go. So let's say the ball is bouncing up and then it's going to come back down. Let's say behind it we have paper with 10 centimeter marks on it. So there's 50 centimeters, there's 40, there's 30, there's 20, and there's 10. Okay, so let's say we have something like that. And we might count the frames from as it's going up, and it passes the 30 centimeter mark, goes up to the top, comes back down to the 30 centimeter mark. The reason to do it that way is that the ball spends several frames at the top. So it's hard to know which frame to use to count how many frames from the top to the 30 centimeter mark. So if we just go from the 30 centimeter mark up and to the top and back down, and then divide that time by 2, will be way more accurate. And we want to get this within 10%, so let's go ahead and do that step. So let's say we count the frames. Let's say there's 118 frames. And our camera is shooting at 280 frames per second. So if I divide my frames by my 280 frames for 1 second, that will give me the fraction of a second. And that turns out to be 0.42 seconds. And half of that was going down. So if we say 0.42 divided by 2, that tells us that the time going down was 0.21 seconds. So our distance was 0.22. Our time is 0.21 seconds. So that's an average time, or average speed, sorry. And it is 1.05 meters per second. Well, that's an average. In the free fall, at the top of the bounce, it was at 0 meters per second. The average was 1.05. So the final velocity at 30 centimeters must have been twice that, since it's a constantly increasing acceleration. So I got to 2.1 meters per second. And it took me 0.21 seconds to get to that speed. And so that would be an acceleration of 10 meters per second every second. Your number of frames, your distances, everything will be different, but you should come up with an answer fairly close to 10 meters per second every second. We want to be within 10% of that. So it could be so 10% would be 1, so we could go down to 9 and up to 11. Anything between 9 and 11 would mean that our measurements and the calculations are right. If you don't get between 9 and 11, raise your hand, let me look through your numbers with you and see if we can find a mistake.